A transaction is a unit of work that is done as a single atomic operation. That is, the operation succeeds or fails as a whole. A transaction in its entirety can commit to a database as a single logical unit or roll back, meaning you become undone, as a single logical unit. Transactions are essential for maintaining database integrity. An SQL transaction is helpful for executing one or more statements as a set. Transactions are used to preserve integrity when multiple related operations are executed concurrently or when multiple users interact with a database concurrently. If a transaction is successful, all the changes made in that transaction will be applied. If any single statement in a transaction encounters an error, then changes made will be rolled back. Transactions protect against database failure conditions, including power failures, server crashes, disk drive failure, and database software crashes. In the event of one of these failures, if there are transactions that have not yet been committed, database integrity is still maintained. The four main properties of a transaction are known as ACID: atomicity, consistency, isolation, and durability. With atomicity, all of the operations that are included by the transaction are performed successfully. Otherwise, all operations are canceled at the point of the failure, and all the previous operations are rolled back. With consistency, this property ensures that all the data will be consistent after a transaction is completed according to the defined rules, constraints, cascades, and triggers. With isolation, all transactions are isolated from other transactions. For durable, the modification of the committed transactions become persisted in the database. The following commands are used to control transactions: commit, which saves the changes; rollback, which rolls back or erases the changes; save point, which creates points within the groups of transactions in which to roll back; and set transaction, which places a name on a transaction. Transaction control commands can be used with data manipulation language commands such as insert, update, and delete. They can also be used with data definition language commands such as create table and alter table for some databases, such as Postgres, Oracle, SQL Server, and SQLite. Every transaction should start with begin transaction, begin tran, or begin transaction with name. However, syntax can vary depending on the database being used. Every transaction must end with either commit or rollback statements. Commit transaction saves the changes made between the begin and commit statements. Rollback transaction erases all the changes between the begin and rollback statements. Without a transaction, when you execute the insert statement below, the database inserted a new row into the student table immediately. In this case, you do not know when the transaction begins and cannot intercept the modification, such as rolling it back. In this example, the following statements will start a new transaction and insert a new row into the student table. From the current session, you can see the change by querying the student table. However, if you start a new session and execute the same select statement, the change will not be visible since the transaction has not been committed. To make the change become visible to other sessions or users, you need to commit the transaction by using the commit transaction statement. Putting it all together will give us the following. In this example, we will use statements that updates data and inserts data using a transaction. From the current session, you can see the changes by querying the student table. However, if you start a new session and execute the same select statement, the changes will not be visible since the transaction has not been committed. Here we will commit the changes so they are visible to other sessions or users. Putting it all together will give us the following. In this example, we will show how a transaction works with a rollback. We will update some items and insert a row into the student table. Using this select statement, we can see the changes made from the above. Executing a rollback transaction will remove all of the above updated and inserted values. A save point is a point in a transaction when you can roll the transaction back to a certain point without rolling back the entire transaction. We'll begin with two update statements, followed by a save transaction statement named after updates. This defines the section that will be rolled back. Then we'll add an insert into statement. The select statement shows the changes for the current transaction. The rollback transaction after updates will undo the changes up to the named save point after updates, meaning only the two update statements will be undone. The row inserted will remain. We'll complete this with commit transaction. Note that Postgres uses a different syntax for defining a save point and for rolling back a transaction with name. Transaction isolation levels define the degree to which a transaction must be isolated from the data modifications made by any other transaction in the database system. They are a measure of the extent to which a transaction isolation succeeds. In particular, transaction isolation levels are defined by the presence or absence of the following phenomena. A non-repeatable read occurs when a transaction reads the same row twice and gets a different value each time. Here, transaction A reads a row. Transaction B changes the row. Transaction A reads the same row a second time and gets the new results. A dirty read occurs when a transaction reads data that has not yet been committed. Here, transaction A inserts a row into a table. Transaction B reads the new row. Then transaction A does a rollback. A phantom read occurs when two same queries are executed, but the rows retrieved by the two are different. Here, transaction A retrieves a set of rows that satisfy some search criteria. Transaction B generates some new rows that match the search criteria for transaction A. If transaction A re-executes the statement that reads the rows, it gets a different set of rows this time. The SQL standard defines four isolation levels: read uncommitted, read committed, repeatable read, and serializable. Read uncommitted is the lowest isolation level. This level allows transactions to see uncommitted changes to the data, thereby allowing dirty reads. At this level, transactions are not isolated from each other. In Postgres SQL, read uncommitted is treated as read committed. Read committed level means that any changes made inside a transaction are not visible outside it until the transaction is committed. This prevents dirty reads from being possible. The transaction holds a read or write lock on the current row and thus prevents other transactions from reading, updating, or deleting it. Read committed is the default isolation level. Repeatable read is the most restrictive isolation level. The transaction holds read locks on all rows it references and write locks on referenced rows for update and delete actions. Since other transactions cannot read, update, or delete these rows, consequently it avoids dirty reads and non-repeatable reads. However, phantom reads are still possible. Serializable is the highest isolation level. While this isolation level permits transactions to run concurrently, it creates the effect that transactions are running in serial order. Transactions require locks for read and write operations, meaning no other transactions can modify data that has been read by the current transaction until the current transaction completes. Other transactions cannot insert new rows with key values that would fall in the range of keys read by any statements in the current transaction until the current transaction completes. It is important to note that the transaction isolation level does not affect the transaction's ability to see its own changes. Transactions can always see any changes they make. The transaction isolation level can be changed using the following SQL statement. The table below shows 4 transaction isolation level phenomenon that can occur. The transaction isolation level phenomenon that can occur for PostgreSQL is different. For read uncommitted, here dirty reads cannot occur. This is because read uncommitted is treated just as read committed. For repeatable read, phantom reads cannot occur. I hope you found Introduction to SQL Transactions helpful. If you have, click on the like button. And to receive updates to this channel, click on the subscribe button. Thank you so much for watching.